Alright, my last couple videos, we are finally on Unit 2, Topic 2. And this is my favorite topic, trig and right triangles. So, here we go. So, opposite of angle A. So, here's angle A, and opposite, you look across, is BC. Opposite of angle C. Here's C, you look across, AB. Okay. Sine is so, ka, toa. Okay, so sine is going to be O over H of angle A. So here's angle A. Opposite is BC. And the hypotenuse never changes, so I always put H for hypotenuse. It's across the 90. So the H is AC. Alright, cosine is adjacent over hypotenuse. Again, hypotenuse never changes, so it's going to be your AC. And the adjacent of angle A, well, this would be your opposite, so this has to be your adjacent. So it's AB over your hypotenuse, which is AC. Alright, tangent is O over A. So opposite of angle A is BC. And adjacent of angle A is AB. Alright, that's all for angle A. Now they're changing for angle C. So for angle C, this is the opposite, making this the adjacent. And hypotenuse again doesn't change. So the sign would be opposite over hypotenuse. So AB over AC for the hypotenuse. Cosine, adjacent over hypotenuse. BC over AC. Tangent, opposite over adjacent. AB over BC. Alright, so which angle has BC sine as BC over AC? So opposite needs to be BC. That would be angle A. Tangent is AB being the O, A, OA, TOA. Okay, AB is the O, BC is the A. Boop. Alright, so if you want AB to be the opposite and BC to be the adjacent, then you need to you need to talk about angles. Right? And lastly, the hypotenuse never changes. It's always across the 90 degree, so it is AC. Alright, moving on. 54 is a tough problem, alright? So for 54, I would just check it using my calculator. So if you're using a graphing calculator, you want to make sure that you're on degree under mode, not radian. So let ABC be a right triangle. So I'm going to put a 90 degree here with right angle at C. Which statements are true? Check all that apply. So you know that this angle and this angle have to be 90 because the three of them need to be 180. So I'm going to make this the 30, 60, 90 triangle. So as you can see, these all add up. Right? Just for my example. So they say that angle A and angle B are complementary. Like C starts with a corner, 90 degrees. Complementary means that they add up to 90, and you can see that 30 and 60, A and B, do add up to 90. So this is true. Alright. Angle A equals 90 minus 2. Let's just put in angle A. Angle A is 60 equals 90 minus my angle B is 30. 90 minus 30 is 60, so this looks like it's true. Alright, so when I put tan of angle A, which is 60, angle A I'm going to change to 60, cosine I'm going to change to 60. So when I put tan of 60 in my calculator, I get 1.73. And when I do sine of 60, make sure you close your parentheses. Over cosine of 60, I get 1.73. So that seems to be true, that sine over cosine is the same as tan. Alright, this one, it looks like it's just a squared plus b squared equals c squared. Alright? So that's Pythagorean theorem. That's true for all right triangles. Sine of A So again, I'm going to put 60 here. Cosine of b, so b is 30. So I'm going to see if sine of 60 is the same as cosine of 30. So sine of 60 is 0.866, and cosine of 30 is 0.866. So that seems to be true. All right. The cosine of angle A, which is 60, is it the same as sine of 90 minus angle A, which is 60? All right. So cosine of angle 60, I'm using my calculator, is 0.5. And the sine of 90 minus 60, close your parentheses, is also 0.5. That seems to be true as well. Oh my gosh, all of them are true. All right, on your exam, just don't mark all of them true just because these are all true, okay? All right, if angle A equals angle B. Uh-oh. So in my case, they don't equal. They have to add up to 90 though. So if they do equal, that means that they would both have to be 90 divided by 2, which is 45. Right? So it would be a 45, 45, 90. Then the measure of angle A must be 45. That is also true. So I guessed and checked all of them and found that all of them are true. All right, number 55. Sandra says that since the two triangles are congruent, okay, because 12 matches with 12, 16 matches 16, and 20 matches with 20. So these two triangles are identical twins, congruent by side, okay? So she says that since they are congruent, sine of A equals sine of B. Is Sandra correct? Huh. Okay, so let's do the sine of A. So sine is opposite over hypotenuse. And the sine of B, here's angle B, opposite over hypotenuse. 12 over 20, did I do this right? Opposite over hypotenuse? Opposite over hypotenuse. Okay, I guess she is incorrect. Because 12 over 20 and 16 out of 20 are completely different. So 12 out of 20 is 0.6 and 16 out of 20 is 0.8. So I would say that Sandra is incorrect. No. 12 out of 20 is different than 16 out of 20. Alright, moving on. Number 56. Alright, here we go. Again, I see a triangle inside the other that makes me really uncomfortable. So I'm going to draw the small triangle here. 6, 8, 10. 6, 8, 10 with my 90-degree angle here. And the big triangle, like that. This is 15. This side is your 12 with the 8, which is 20. And this side is 15 with 10, which is 25, right angle here. All right, so don't forget to add up your sides. All right, here we go. Letter A. Show that the value of cosine of S, so here's S, so S is located right here in the big triangle and right here in the small triangle. It's the same for both triangles. All right, so cosine is adjacent over hypotenuse. So the cosine of S in the big triangle is adjacent over hypotenuse. So it looks like across the 90, that's your hypotenuse. Across the angle, that's your opposite. And this would be my adjacent. So it's going to be 20 over 25. Adjacent over hypotenuse. And in the small triangle, the cosine of S, same thing. Here's your hypotenuse. Across your angle, there's your opposite. And this is your adjacent. And the only reason you can use SOHCAHTOA right now is because it's a right triangle. Alright? You cannot use SOHCAHTOA if it's not a right triangle. So cosine of S for the small triangle is the adjacent 8 over the hypotenuse 10. Now if you look at these numbers 20 over 25 and 8 over 10, they don't look the same. But if you actually put in the calculator 20 over 25, you'll get 0.8. And 8 divided by 10 is 0.8 as well. So the value of cosine of s is actually the same for both. All right, part B. What is the value of sine of u? So I'm looking for u, and it looks like u is here in the big triangle. All right, so I'm going to use that. I'm going to erase some of this. And notice how I always come back to my angle first. Okay, so here's angle u, and they want the sine of u. So sine is so. So the sine of angle u equals the opposite, which is here, 20, over the hypotenuse, which is across the 90, 25. All right. So last one, is cosine of u the same as cosine of t? So t is here in the small triangle. All right. So the cosine of u in the big triangle would be the adjacent, which is 15, over the hypotenuse, which is 25. And the cosine of t in the small triangle, let me erase this. So here's angle t. So again, this is the hypotenuse. Across angle t, that's the opposite. And this is the adjacent. So cosine is adjacent 6 over hypotenuse 10. So 15 over 25 in your calculator. If you do it, 15 divided by 25, I get 0.6. And 6 over 10 is also 0.6. So the answer is yes. All right. All right, let's try to squeeze one more question in. Actually, I'll do that in the next video. So thank you. That's up to 50.